We're now going to start building our final sets of identities that we need for our trig class. Okay. In the last video, we came up with and derived the formulas for the angle sum and differences for cosine and sine. Of course, here we see the cosine and you'll recall the sine values as well. Well, from those we can easily derive the double angle identities. The double angle identities ask for what is the sine of 2x? Well, obviously 2x is x plus x, so the sine of 2x is going to be sine of x plus x, which we can now call upon our angle sum formula for the sine and say that sine x cosine x plus cosine x sine x, which of course can simplify down to 2 sine x cosine x for the double angle sine. Okay, so that's a good formula to remember for the double angle sine. Okay, and let's do the cosine. The cosine, of course, likewise is going to be cosine of double angle is cosine x plus x, and then we recall the angle, the summation form for the cosine is cosine cosine minus sine sine, so that's cosine times cosine x times cosine x minus sine x cosine squared minus sine squared is the double angle identity for the cosine. Now, because the cosine squared is actually 1 minus the sine squared, we can actually incorporate that and come up with an alternate name for the double angle cosine, which is, as you can see right here, cosine of 2x is 1 minus 2 sine squared x. And you might say, well, why couldn't we come over here and say that sine squared is 1 minus cosine squared? Well, in fact, we can. That's what we're going to do over here. Sine squared is 1 minus cosine squared. So when this is all said and done, we end up getting this as an alternate form for the cosine of the double angle. So we have now, okay, 2 new identities, but then the double angle cosine actually goes by three different names, and it's worth knowing all 3 of them. Of course, if you remember the cosine squared minus the sine squared, these other 2 will naturally come about. Now, these other 2 are going to be used as the basis for our building yet one more and one last set of identities, the half angle identities. So we're going to start with these as our bases and move on to find what we call the half angle identity. So here we go. We're starting with these 2. Okay, now we'll work on these one side at a time. This will afford us to find a half angle identity for the sine. This will afford us to find a half angle identity for the cosine. So here we go. Okay, if we do a little substitution here for the time being, that if we allow 2x to be replaced with the value of p, then you will agree that x is half of p. All right. Now what I want to do is I want to solve for the sine of the half angle right here. So I'm going to isolate that sine squared term, as you can see here. I'm going to subtract 1 divided by -2. Now, invariably, I would think we're going to have a red flag go up because we're going to be asking for the sine, not the sine squared. So you're going to be taking the square root, and you're going to be saying, whoa, what about the square root of something with a negative? Well, we're just going to do a little shuffling around here. I'm going to rearrange the order of subtraction in the numerator at the expense of wiping out that negative term in the denominator. So by and large, we end up with the half angle formula for the sine, half angle formulas for the sine as the plus or minus root of 1 minus cosine p over 2. We can use the same rationale over here to come up with the half angle formula for the cosine, again doing the prescribed substitution here. Now we're going to isolate this for the cosine of the half angle, and hopefully you can see that. Just simply add 1, divide by 2, then we take the square root, and now we have the half angle formula for the cosine. the half angle formula for the sine. Okay, so those are basically, they're not all of the major trig identities, but they're pretty much the ones that we're going to have, that we're going to need for our purposes. And in another video, I will discuss some applications of these. Here, we were at least able to see the derivation of them, and hopefully you can appreciate that. Okay, there you go.